Hey, it's Tyler with Deep Code, and in this segment, I'm going to be talking about reentrancy. I like to define reentrancy as the ability of a callable to be called multiple times concurrently without one call affecting the state of other calls. Given the code here on the screen, before I demonstrate some problems that might arise for code that's not reentrant, if you want to quiz yourself, consider this code running concurrently by two or more threads on a single CPU with a single core. The print statement might print some values that would surprise us. If you want to think about that, go ahead and do that now. Otherwise, I'll get to explaining it right now. So for visualization's sake, we have the same code split on either side of the screen. The left side will be thread 1, the right side will be thread 2, and I'll walk through some control flow to demonstrate what might happen to print some surprising results for functions that are not reentrant. We're going to track the state of I as we walk through the code here. The highlighted line, I'm going to indicate the line that has just been executed. And we only have one instance of the value I in that box at the bottom of the screen because the variable I has static storage. And so it's initialized before main, and we share one value of it across all the threads. So thread 1 is active and running on the CPU, and it has just finished. Thread 1 is just called foo, and we've just entered the scope of foo here. Now, as I just explained, the static storage duration of I means that this initialization happened before main, and so the statement here is effectively a no-op in the control flow, so we're just going to skip over it. And we will get to the point where we increment I by 1. Now, at this point, I'll use a darker highlight on thread 1 to indicate that thread 1 was suspended by the CPU. So it was put into waiting mode, and thread 2 is now the active thread. And hypothetically, thread 2 has called foo now, with thread 1 kind of in the middle of foo and put on the stack. Thread 2 is called foo, and we've just entered the scope of foo. So for the same reason, in thread 1, this is essentially a no-op. We skip that. And now thread 2 increments I by 1. Now the shared value of I is 2. And thread 2 will proceed to go and print the value of that. We'll see 2 wherever this is printed on stdout, for example. And we'll fall off the end of the function there. And then hypothetically, thread 2 finishes, and thread 1 is put back as the active thread on the CPU, and it picks up where it left off. And now thread 1 is going to call its print statement, and it's going to print 2 as well. And so in this case, this hypothetical runtime never printed the value of 1, and both threads printed the value of 2. So this is an example of some code that is not reentrant. Again, reentrancy would be the ability of a callable to be called multiple times concurrently without one call affecting the state of other calls. And in this case, because there is shared state between these two copies of the same code, or rather the same code being run by two different threads, there's shared state by the static I, this code is not reentrant. Now, going about making this code reentrant is actually a little bit nuanced, and it depends on the context in which you're going to run your program. So, for example, if you didn't actually need to share the value of I across threads, you could use thread local storage. If you did need to share the value of I across threads, you could use mutexes or some kind of synchronization primitive to lock around the value of I. But if you do mutexes, if you have locks, then you also need to take into consideration whether or not this particular function would be called by an interrupt if you do have interrupts in your runtime, and an interrupt handler might call one of these things. In that case, you might need to disable interrupts, so that way you don't deadlock waiting for a mutex to unlock if you were to preempt a call to foo with another call to foo in an interrupt service routine. So that's all for reentrancy.